recording. I am Elamurugan of grade 12A, where I am going to present equipotential surface. Any surface that has same electric potential energy at every point on it is called equipotential surface. It may be a surface of a body or surface in space. We can draw equipotential surfaces throughout the region in an electric field. Some important properties of equipotential surface are: no work is done in a moving test charge over an equipotential surface. Electric field is always perpendicular to the equipotential surface. The spacing between the equipotential surface enables us to identify the regions of strong and weak fields. Equipotential surface are never intersect each other. Thank you. Good evening, everyone. We are going to see Coulomb's law. The Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of their charges Q1 and Q2, and it inversely proportional to the square of the distance between the 2 point charges, the separation of the 2 point charges, that is F is inversely proportional to R square. So from this we can derive the expression F is equal to F is proportional to Q1 Q2 divided by R square. To remove the proportionality constant, we introduce a constant, that is K Q1 Q2 divided by R square. This K here is equal to 1 by 4 by epsilon naught. The epsilon naught is the permittivity of free space. The K value changes by with respect to the medium that is the charges are kept in. So here the equation for Coulomb's law is F equal to 1 by 4 by epsilon naught Q1 Q2 divided by R square. With this is known as Coulomb's law, Coulomb's equation for force. With this we can calculate the force of attraction between any 2 point charges or force of repulsion between any 2 point charges in which they are separated by a distance r. Thank you. Good evening, everyone. We are going to see about Bohr's atomic model. Before seeing Bohr's atomic model, we will know the reason why he proposed to do so. Bohr was assistant of Rutherford. When Rutherford's model was a failure, Bohr came with a certain modification by adding quantum hypothesis. He gave some postulates first postulate states that an electron in an atom revolves around in certain orbits without emission of radiant energy, which in contrary to the electromagnetic theory. Each atom has a certain stable state in which it revolves. When an atom revolves in an orbit, it emits some radiation while traveling. So this was the electromagnetic theory. He told that is it does not emit any energy because of its stable state. And the second postulate is that electron revolves around the nucleus only in those orbits which has angular moment of some integral multiple of h by 2 pi. H is nothing but the Planck's constant and divided by the constant 2 pi. Nh by 2 pi. This is commonly known as quantization of charge. N is some integer like 1, 2, 3 and so on. The third postulate is that the electron might take transition from one orbit to another. When it do so, a photon is emitted having energy equal to the energy difference between the initial and final stage. When an electron travels from one orbit to another, if it is here, it goes to another orbit here, it absorbs some energy. It goes to the excited state, and it obviously is not stable, and it tends to come back to the original orbit. So it comes to its original orbit. When it emits some energy, it will have some frequency. It is given by the equation h nu is equal to ei minus ef. This is all about Bohr atomic model. Thank you.